I'm Hassan Obaid, and in this video we will discuss the basic functionalities and applications of transfer switches. Cummins has been designing power transfer controls for over 40 years. An automatic transfer switch, commonly known as ATS, is used to transfer power between two different power sources. For example, the transfer switch can be used to transfer power between two utility sources, two generator sources, or the most commonly used application, utility to generator set. Here's an automatic transfer switch. The key components of an ATS are the switch mechanism, the control, and enclosure. The control is mounted on the outside of the door. If you open the door, you will see a mechanism like this. Now I will talk about the major functionalities of an ATS: power transfer, load shed, and exercising. Here is the mechanism of a 3-pole, 3-position transfer switch. The loads can be connected to the normal source, typically the utility, or to the generator source, or to neither source, also known as the center off position. Let's see this again. The loads now are connected to the utility source. The loads now are connected to the emergency source, or connected to neither source. When the ATS control senses that the voltage and/or frequency of the utility are not within the acceptable limits, it sends a start signal to the generator. When the generator set is ready to accept load, the ATS transfers the load to the generator. Once the utility source returns and becomes stable again, the ATS automatically transfers the load back to the utility and removes the start signal from the generator to allow it to shut down. This transfer switch is a 4-pole, 3-position transfer switch. 3 phases and a neutral, A, B, C, and a neutral. The utility can be connected on this end, while the emergency source can be connected on this end, and the loads are fed from this end. Notice how the 3 phases and the neutral are connected to the same connecting rod. So when the transfer switch transfers, all 3 phases and the neutral are moved simultaneously. There are also 2-position transfer switches that do not have a center off position. The center off position is used for delayed transitions and load shedding. Since transfer switches are offered in a 3-pole or 4-pole configuration, to determine which one to select, attention must be paid to the system grounding scheme and ground fault protection requirements. If ground fault detection is required, a 4-pole transfer switch is necessary in most cases. The U.S. National Electric Code allows the alternate power source to supply emergency, legally required, and optional system loads where the source has adequate capacity or where the automatic selective load shed is provided as needed to ensure adequate power. The transfer switch can receive a load shed command from a generator or a system-level control such as a DMC. When the command is received, the ATS transfers the connected load from the generator to the center off position to prevent the generator from becoming overloaded. Let us demonstrate this. In this position, the loads are powered by the generator. When the ATS receives a load shed command due to an overload, the ATS moves to the center off position and the load is not connected to any power source. The ATS remains in the center off position until the overload condition is resolved, by an operator for example, and the load shed command is removed. When the load shed command is removed, the ATS moves back to the generator. In addition to transferring loads and load shedding, ATSs can also be used for testing and exercising generator sets to meet relevant code requirements such as NFPA 110 and ensure system reliability. In this video, we discussed the basics of transfer switches and applications. In the upcoming video, we will discuss transfer switch transition modes. Thank you for watching.